Great. So first, I want to make sure I acknowledge my colleagues, Guanling Chen of Monash University, as well as my Stanford colleagues, Kathy Mizrahi and Andreas Pepke. Now, let's get to it. So the basic purpose of this study was we ran a randomized controlled trial for 6 courses on Stanford's Loganeta platform, and we randomly assigned individuals to watch courses either at 1.25x or 1.0x speed. And so the key takeaways we found from this is that students who are assigned to go faster get higher grades and were more likely to complete the course. But these same students, in fact, actually on average spent less time watching videos, yet completed more of the video content. And the things that I'd like you to take away from this is that this is a type of intervention that is very cheap and it seems to boost course completion rates. And in addition to that, it lends some credence to some of the discussions around why MOOC attrition is so low. That in fact, what it suggests that why students fail to complete courses isn't necessarily a time management problem, but it's a time resource problem. And lastly, I think what I want you to take away from this is that playback speed is a potential hyperparameter you can use or tune to optimize course completion. So,
David, I'm going to just hop in here. We are seeing on the right-hand side of your slides a big black box. I don't know if you've got anything else up on screen or if it's just a glitch of Zoom. Oh, that's it.
I think it's just a glitch.
Right. Okay.
Yes, and as I was saying, one of the reasons why this work is so topical right now is that many universities are currently facing a challenge in light of COVID-19 of having to move all instruction online. And one of the obvious choices that they're going to have to face is whether or not they're going to choose synchronous or asynchronous instruction. And what that means is a synchronous form of instruction offers a lot of fidelity and it's much more interactive. But asynchronous instruction also has some advantages in that students have more flexibility in how they consume educational content. They can choose when they want to learn, as well as what speed to learn. And as I mentioned, the sort of broader motivation for why we started this work is we found that most MOOCs had low completion rates and low persistence. And when we dug into the associated survey work, we found that the way people typically interpreted why students failed to complete MOOCs was that it was due to time constraints or time management issues. And when you connect that with the larger elements of the educational literature, we found some very interesting and sort of interesting stylized facts that seem to be at odds with one another. One of which is that college students generally have continued to spend less and less time on academics over the past several decades. And yet when we also look at the K-12 literature, we found that increasing instructional time actually tends to have a pretty large impact on student test scores and other educational outcomes. Now, one of the things that I want to mention is we really went into these survey items. And one of the things that I find kind of interesting that in work by Narad and Dosa is that about 52% of the times that students withdraw from MOOCs, they cite time being the primary issue. But in often when I see this paper referred to in literature, it tends to be focused more on time organization. But in many ways, I feel this is more a time endowment problem, and that it's talking about people having conflicting real-life responsibilities, that the course is just taking up too much time. So that got me thinking, what if we could artificially shrink the amount of time that a course takes? And so what we're doing here is we're artificially reducing the temporal cost of consuming a particular course. And we think that might also have some downstream effects on how students might engage in self-regulated learning. So then does exposing students to faster content affect how they might use these compensatory strategies? And finally, does increasing playback speed improve course performance and course persistence? Now, the way we try and operationalize this is my background is in economics, so I tend to think in these classical microeconometric terms. And what I assume that an individual who's trying to learn in a course will do is that they will have some sort of knowledge function that is a composition of how much they engage in formal learning, that is attending lecture, and how much they engage in what I'm going to call informal learning, which is self-studying and reading. And I chose this production function where alpha and beta are scaling factors, but most of these results will hold with other generalizable results. But we are going to assume that individuals try and maximize the amount they learn subject to a budget constraint, meaning just how many hours they have in a day to devote to their learning, or just how many hours a day they have in general. And we treated this very formally. We ran this as a Lagrangian optimization problem. And one of the things that we found when we adjusted playback speed is we've effectively artificially lowered the price of consuming a formal unit of education. And what our analytical models suggest is that individuals will effectively split their time across these learning activities according to their relative cost and returns to each activity. So in effect, what we think that increasing playback speed should do is it should increase the amount of video content that individuals assume. And to give you an illustration of this fact, we first start off with an individual who can consume informal and formal learning with equal cost, that they just have this blue line for their budget constraint. And then this red line corresponds to the optimal consumption bundle that an individual can consume before this playback speed technology is introduced. And then we shift the video playback speed to 1.25x, and we sort of see that there's this new budget endowment where individuals could choose to spend time between formal and informal learning in different allocations than was feasible beforehand. And what effectively that means is, in our analytical model, is that a student won't change how much self-study they engage in, but they will actually consume more video content, more video lectures. And just to zoom out a little bit on prior literature on playback speed is that there hasn't been much work in a MOOC setting before. That typically when people have focused on variation in playback speed, they've been more focused on short interventions around 1 to 2 hours of instruction. And moreover, that they tend to focus on large steps in speed, 50% or more. So what I think might be helpful to think about is that few studies have focused on smaller speed changes, and even fewer have looked at this long horizon where individuals are allowed to compensate through self-regulatory strategies. And on that front, one of the things that I really want to emphasize here is that I know this seems fairly trivial, but modifying playback speed has diminishing returns to scale. That going from 1 to 1.25x has a 20% reduction in time, but going from 1 to 1.5 is 1/3, and going from 1 to 2 is 1/2. So meaning basically for every little bit you go faster, you gain even less and less. So there's a lot of reasons to think that focusing on these narrow regions are where you're going to get the most bang for your buck. And coupled with that, we also know a fair bit about how humans are able to process dialogue and engage in audio comprehension. And generally, we know that individuals seem to be able to listen at a cadence of around 150 words per minute. And just as you start to go faster and faster, individuals lose audio comprehension, and people speculate that there's a bit of a cliff at around 250 words per minute where individuals are able to lose retention of knowledge, of whatever they're listening to. And just generally, there have been many improvements in audio technology since MOOCs have launched that, in particular, the audio chipmunking effect, where pitches of an individual go up. There are now signal processing techniques that can compensate for that. So you would sound, these individuals sound normally to the listener. So the data that we're using comes from 6 MOOC courses. They have varied subject content ranging all the way from database courses to statistics to even a writing course. And they also have heterogeneity in terms of their length and duration, ranging anywhere from 2 hours to more than 24. We had 6,000 students enroll in all of these across all of these courses, and our hypotheses were pre-registered at the Open Science Foundation. But before we get to that, I just want to give you a sense of what the cadence of the accelerated video looks like. So I just want to play a short clip.
This is the first of 7 videos where we're going to learn the SQL language. The videos are largely going to be live demos of SQL queries and updates running on an actual database. The first video is going to focus on the basics of the select.
So you can get a sense of how fast that sounds. It might sound a little bit accelerated, but within the range of what, within the variance of what you might already hear from instructors or faculty or colleagues. And one of the other facts that we found that was also just interesting, when we looked at prior administrations of these courses, we found that variable playback speed was not commonly used in terms of, by the individuals who enrolled in these courses. About 1/5 of students modified their playback speed, and of those who modified, the average playback speed was only around 1/3, sort of suggesting that prior studies might be overshooting on what students prefer when they have discretion in choosing playback speed. So the way we hypothesize how students will react to this sort of these sped state videos are the following. First, we know that video content is finite in these courses, so we think that students who are exposed to sped content will just experience time savings. Second, we think that students who are exposed to sped video content will, as a corollary, consume more of the course content. And third, we think that these students might exhibit differential behavior in terms of self-regulatory behaviors such as pausing, rewinding, and reflecting. And finally, we believe that students will also take some of their time savings in these courses, and that will translate to better grades because they will have more time to devote to these efforts. The estimation strategy that we're using for this analysis is very simple. We have whether or not an individual is assigned to watch videos at 1.25x speed, and we also include a course fixed effect because, as I mentioned earlier, that there is a lot of heterogeneity in terms of a course's length and other characteristics. So let's go into our results. And what we found was that on average across these courses, students saved roughly 25 minutes or more if they were assigned to a treatment group. And this also translates into students consuming marginally more content. On average, they consumed extra 0.4 videos or lectures per student. If they were in the treatment group. And with self-regulatory behaviors, it's a bit of a mixed bag. So the way I thought about this was that if students are sort of disengaging with this content, we would see fewer pauses and fewer rewinds. If students were engaged in the content, we'd see more pauses, more rewinds, And in fact, what we got was kind of a mixed bag. So I'm not quite sure how to frame this analysis, but I think it's clear that individuals interact with videos differently in these sped states. And finally, when we get to our focal outcomes of grades and course performance, we see that students who are in this fast treatment group have test scores that are roughly 2 percentage points higher. That throughout the course they get better grades. And this, I want to be transparent about the results here. And this seems to be largely an artifact of the fact that MOOCs have high attrition, and that students who are assigned to the fast treatment group attempt more content, and they attempt more content, and that seems to be the artifact here. Beyond that, we also see that this effect isn't just concentrated in individuals who drop out, that this translates into individuals being about 2.6%, being more likely to obtain a certificate or pass the course. It's a difference of around 2.6 percentage points. And then the next step was we tried to examine heterogeneity across courses. We can see here that there are pretty large differences in effect sizes across courses. So for instance, in our SQL course, we saw that there was nearly a 5 percentage point jump in the pass rate. Whereas in our CS and medical statistics courses, we saw very little changes. One thing that we did to sort of frame these effect sizes was we used meta-analyses techniques, standardized the effect sizes, and then computed the meta-analytic averages. And what we found was that for the most part, we saw very little heterogeneity across courses in terms of the effect on grades. Again, it's really important to keep in mind the effect size here. This is only 6/100ths of a standard deviation. So we're talking about very small effect sizes. When we looked at the time savings that students experienced, we see some modest evidence of heterogeneity, that in fact the students who were enrolled in the SQL course experienced a time savings on the order of a 20th of a standard deviation. And for the record, that was actually in fact the shortest course. So I think that might be an artifact of the fact that students were able to just go through and complete the course in an entire day. And finally, the last thing we looked at was whether or not there was any evidence of heterogeneity by student. And there are lots of reasons to think that might be the case, that if a course was taught in a language that was not a student's native language, that accelerated content might be bad for that individual. Additionally, there are various literatures suggesting that individuals lose the ability to hear sped as they age. So what we did to sort of look for heterogeneous treatment effects in a researcher agnostic way was we used a technique called random forest, where in effect it's very analogous to decision trees, where you build decision trees with the goal of maximizing the difference between treatment and control groups. And then you evaluate that model on a disjoint set of observations, and you repeat that process many times until you get a forest-based estimation. And the sort of demographic variables we threw into this model were a student's country of origin, their gender, their age, and their educational attainment. Again, these are very coarse variables, and what we found was largely that in terms of variable importance, that none of these factors were particularly important, that this scale can be thought of as being on a 0 to a 100% scale, and this is the factors that were most important we found were age, whether or not a student identified as male, and whether or not they identified as coming from the US. And when we actually looked at evidence of model heterogeneity by these characteristics. We found very little variation in the effect size across these groups. That the effect size on grades varied basically from 0.04 standard deviations to 0.06. And it's a similar picture in terms of the time savings that students experience, basically anywhere between 3 and 400ths of a standard deviation. So the things that I'd like you to take away from this is that while these effect sizes are small, the implementation cost of this type of intervention is also very small. And what we see is that when you reduce the temporal cost, the sort of length of the course, we've seen increases in course completion. And so what this suggests to me is that part of the reason why MOOCs had such low attrition rates and low completion rates was that, in fact, it wasn't that students had time management problems per se, but that they just had very real and very binding time constraints. And finally, it also suggests that there are ranges of playback speed where video speed can be increased and learning is unaffected. Of course, there are caveats to this work. In terms of where I'd want to take this is that MOOCs have notoriously high attrition and low completion rates, and largely what we are seeing is the fact that students persist longer when you accelerate this video content. So I have no idea how it will generalize to a college environment where students are likely to complete courses to begin with. And then, of course, there's always internal validity concerns about the item quality. Many of these items tend to be recall type questions, so we don't know how it will generalize. So issues pertaining to long-term retention. And where I'm taking this in the future is we've cast some doubt that 1.0x isn't optimal, but we haven't proven that 1.25x is the right speed either. What currently I'm doing is I'm running another iteration of this experiment where we vary playback speed all the way between 0.75 and 1.75 speed. And hopefully we'll have those results in a few weeks. And of course, I'd like to acknowledge my funders, the Institute for Educational Sciences, Stanford University, as well as the Vice Provost for Teaching and Learning for providing us this data. Thank you so much.